Alright, example 5. Solve by using a table. So we're going to solve this quadratic rounding to the nearest hundredth, which, if you remember, hopefully is 0.01 to the second decimal place, right? Which means if we're going to round, we're going to use that third decimal place to determine whether it goes up or stays the same. But really, what's going to happen here is our solution is going to say between one x value and another x value, between one x value and another x value. And we just got to figure out what those x values are, and there's going to be 2 decimal places for it. Now, I originally had these videos for GeoGebra. I am going to show you how to do this on NumWorks. So the first thing I'm going to do is I'm going to go to NumWorks, and I'm going to go to the Functions tab, click OK, and OK again to add a function. And I'm going to go ahead and type in x squared minus 6x minus 2, and that is equal to 0. So we should be good. Go ahead and click OK. And we can plot the graph if we want to, but I'm not using the graph to actually find it. I'm using the table of values. So I'm going to go to Display Values and click OK. And you can see my normal value range isn't very helpful. What I'm looking for is changes in the y, or the function output, from negative to positive. And I can see I've got one here from between 6 and 7. It goes from negative 2 to 5. So that's going to be where one solution is. But I don't see where it is in the other side. I see I got a negative 2. But if I go up to set the interval, let's change the start value to negative 5. And then confirm that. And yeah, positive to negative y value, and negative to positive y value. So now I've got my 2 ranges. So I'm just going to make a little note on my page. Negative 1 to 0, and 6 to 7. Now what that looks like on my other page. So I just kind of wrote down, these are some basic ranges of where these solutions are going to be, but I need to narrow it down even further. So when I go to NumWorks, I go backing up to set the interval, and I click OK, and let's find between negative 1 and 2. So I'm going to make the x start negative 1 and the x end 0, and I have to change the step to 0.1. Now I could change it to 0.01 and look for the hundredths right now, but I would literally have to look through 100 numbers. Right now I'm narrowing it down to have to look through 10 numbers. Go ahead and click confirm. Scroll on down, positive, positive, positive outputs. There we go. So now I can see that the outputs on the right hand side here go from positive to negative, so the 0 should be between the positive and the negative. So now I'm going to change this to between negative 0.4 to negative 0.3. And you can see just on my work on my my slide, you can see I'm just kind of making notes of the stops along the way. But now I got that new range. I'll go back up to the interval. This is basically what GeoGebra does too, but I thought I'd try to be consistent here. The start will make it negative 0.4, end negative 0.3, and this time the steps we want to be every hundredth. And go ahead and confirm. Scroll on down until you see a change from a positive to a negative, and to me, there we go, between negative 0.32 and negative 0.31. So negative 0.32 to negative 0.31. And on my page, that's my first set of solution ranges. I don't know exactly what it is, but I know it's between those 2 values. And when you're doing a lot of like actual engineering work or something with something like this, you pick a particular value that you want it to be good enough to, and then you go and you find it. You don't actually, because most of the time, nice solutions don't exist. So let's go ahead and continue on with this. Um, what's another method to do this? Like I could keep doing the table thing again, or you could just watch the video if you like the table method. But let me go up to the graph here. Let me take a look at the graph. And you can see I've got this graph here, and I can press the points here, and it looks like, oh, between 6.8, so 6.4, between 6 and 6.4. So that would narrow it down a little bit right there. I'm between 6 and 6.4. But I'm going to show you something kind of neat here. If you press OK when you're in the graph view, you get options like calculate, go to, derivative. That's something for calculus. You don't have to worry about that. But I'm going to calculate. I can calculate the minimum or maximum. Those are always nice. But I also can calculate the zeros. So I go ahead and just click zeros, click OK. And now I have, see the first root there is negative 0.3162. Sorry, negative 0.316662. There we go. That's where the function 0. And if I press the right arrow, hey, look, there's the other one, 6.3166. So the question is, how am I going to translate to the nearest hundredth? Because I don't want you to write down that whole thing. That's not what the answer is asking for. It's asking it rounded to the nearest hundredth. So it's going to be between two numbers. So I'm going to write what this looks like for this one here, where we've already done the work. And then I'm going to write down what the other one looks like so we can talk about how to write it down as an in-between. Okay. And I don't need NumWorks anymore. Okay. So what we just wrote down was negative 0.31662. And if you notice, my answers are between 0.32, which would be this number moved up one decimal place, so 0.32 negative, sorry. And it floored cut off, so 0.31. So you can see like that position is telling us what we're doing, and we're either going above it or below it, right? So we're either rounding down or rounding up. If we take a look at the 6.3166, rounding down is 6.3, and then take it up one, and 6.4. And there you go. There are your two roots that the other one is between. Oop, sorry. I just did that to the nearest tenth. I wanted the nearest hundredth. So look at the 1 there. So down would be 6.31, up would be 6.32. And there you go. Now we got our answers rounded to the correct area. But that calculate option, calculate with this, pretty handy. We're going to use that on the next example as well.